Lesson 3.4, Properties of Logarithmic Functions. In this lesson, we're going to learn how to expand and condense logarithms, as well as learn how to use the change of base formula, which allows us to calculate a logarithm written in any base.
Hi, right here is John Napier. He is a Scottish mathematician who invented logarithmic functions, Hope you enjoy this. I think you got a good lesson ahead of you.
To start this lesson, we need to go through a few properties that we're going to use when expanding and condensing these logarithms. The first one is the product property, which says if we have a logarithm with a base and two factors being multiplied within our logarithm, we can break this apart into two separate logarithms with the operation of addition. So if we're multiplying two factors within our logarithm, we break this apart into two logarithms using the operation of addition. Similar idea for the quotient property. If we have a log with our base and we have two factors being divided within the logarithm, then we break this apart into two separate logarithms using the operation of subtraction. So multiplication relates to addition, division relates to subtraction. And then the third most common one we're going to use is the power property, which says if we have a value within our logarithm raised to a power, we can simply bring that power, that exponent, down as a coefficient. Okay, so these are the three main ones: product, quotient, power. The equality property is pretty straightforward. It says if we have a logarithm with the same base set equal to each other, then the values of the logarithm must be equal to each other as well. Then off to the right, you can see examples showing each of these different properties. Also be aware that we can go vice versa when we're going to condense. So if we have logarithms, two that are being added, we can combine that using multiplication. Example 1, expanding the logarithm of a product. So we're going to take this logarithm we're given and break it apart using the product rule, and then we're actually going to have to use the power rule after that. So if we look, we have three different factors in this problem. We have 8, we have x, and then we have y to the fourth. So in the end, we're going to have three separate logarithms. So first, we can break this apart. We have log of, this is our common log, base 10 if it's not written in. This is understood to be the common log. So we have log of 8 plus, now we go to our second factor, breaking this apart using addition because they're being multiplied. Now we have log base 10 of x plus log base 10 of y to the fourth. So since we had three things being multiplied, we have three factors, we have to use the product rule, break this apart using addition. Now if we look, we have an exponent on our logarithm. We can bring that down as a power. So the final step we get is log base 10 of 8 plus log base 10 of x plus 4 times log base 10 of y. This is how we break apart, expand a logarithm. Example 2, we're going to expand the logarithm of a quotient. So in this problem, we're going to have to use the quotient property, and then we're actually going to have to use the power property as well. First, we want to rewrite this. It's easier to rewrite this with exponents rather than radicals. So this is the same as the natural log of x squared plus 5 raised to the 1/2 power, all divided by x. So now we're going to rewrite this logarithm. If we have a quotient, we rewrite it using subtraction. So now we have the natural log of what's in our numerator. In this case, it's x squared plus 5 raised to the 1/2 power. We were dividing, so we subtract the natural log of x. Then the last step, if we have an exponent, we have to use the power rule. We bring that exponent down as a coefficient. So this is equal to 1/2 times the natural log of x squared plus 5 minus the natural log of x. And at this point, we're done because x squared plus 5, we have to consider that as one factor. Since we have two terms being added, this is treated as one factor, so we can't do anything with this exponent and apply it to the power rule because this term is combined with this term. So think of this as one factor. Now we're done. Exponent value is 1, so we can't apply the power rule. It's sometimes confusing trying to determine which property you should apply first when expanding these logarithms. So first, you should look for the quotient rule. If you have a fraction, there's division, apply the quotient rule first, then look to see if you can apply the product rule, and then lastly, look to see if you can apply the power rule. So when expanding, look for quotient, product, then power. When condensing, it's basically the opposite. First, you're going to look to see if you can apply the power rule. Then you're going to look and see whether you can apply the product or the quotient rule. This is interchangeable because we're simplifying this going left to right. So if you have a quotient, as we're going left to right, that occurs first, you're actually going to perform that or use that rule before the product. So when condensing these logarithms, we have to go from left to right. The product or quotient, whichever one occurs first, that's the one we have to apply. Example 3, now we're going to condense a logarithmic expression. So if we're going to condense, the first thing we need to do is see if we can apply the power rule, which in this case we can apply to both parts. So we can rewrite this as the natural log of x to the 5th minus the natural log of xy raised to the 2nd power. First we apply the power rule. Now we're going to look and see if we can apply the product or the quotient rule. We have subtraction, so we know we need to apply the quotient rule. So now we can write this as one logarithm. We have the natural log of x to the 5th divided by, and we can distribute this exponent to both the x and y variable. So over x squared times y squared. Now looking at this, we have a common base x being divided, so we can simplify that by subtracting those exponents. Last step, we have the natural log of x cubed over y squared. So condensing a logarithm, first looking for power, then looking for the product or quotient going left to right, whichever one occurs first. Example 4, another example of condensing a logarithm. First, we need to apply the power rule if we can. So this first term we can rewrite as the natural log of x cubed plus the natural log of y, and then minus the natural log of z to the 5th. First, apply the power rule. Now we're going to look left to right if we can apply the product or the quotient rule. First, we have addition, so we can apply the product rule and rewrite that as the natural log of x cubed times y. If we have two logarithms being added, we can combine those into one, condense them into one using the product rule, then minus the natural log of z to the 5th. Now this part, if we have subtraction, that implies we need to use the quotient rule, so we write this as one logarithm. We have the natural log of x cubed y divided by z to the 5th. So condensing a logarithm, writing it as one logarithmic expression. Before we move on to the change of base formula, we're going to go through one more example of expanding a logarithm. Remember, if we're expanding, the order is the opposite. So first we're going to look to see if we can apply the quotient, then we're going to look to see if we can apply the product, and last look to see if we can apply the power rule. So first we should notice that we see a division sign, we have a fraction, so we need to apply the quotient rule. We rewrite this as the natural log of x squared times y minus the natural log of z. Now we're looking to see if we can apply the product rule. We have two factors being multiplied, so we can break that apart using addition. This becomes the natural log of x squared plus the natural log of y minus the natural log of z. Now the last step, we look to see if we can apply the power rule. We have an exponent on our x, so we can bring that down as a coefficient. This becomes 2 times the natural log of x plus the natural log of y minus the natural log of z. So expanding a logarithm, breaking it apart into its individual pieces, condensing a logarithm, writing it as 1. The last thing we're going to discuss in this lesson is the change of base formula. The change of base formula is very useful because it allows us to rewrite any logarithm we're given into either the natural log or the common log, and that's useful because then we can use a calculator to find the value of that expression. Okay, your calculator only works in the common log and the natural log, so you have to use this formula if you're trying to calculate a logarithm with a different base. So what you need to focus on this slide is this bottom portion. If you have a logarithm with a given base and that value, you can rewrite this using either the common log or the natural log. Doesn't matter which one you use. If you're using the common log, just make sure the numerator and denominator both have the common log. If you're using the natural log, the numerator and denominator both need to be in the natural log. So you take the value of this logarithm, that goes in the numerator, so you're taking the common log of that value. Your original base goes to the denominator, so you would be taking the common log of your original base. Okay, so you're rewriting this using division. So now we're going to go through an example applying both of these. It doesn't matter if you use the common log or the natural log, as long as you have the same base in the numerator and denominator, it's going to calculate to the same value. Now example 6, the last example, we're going to talk about applying the change of base formula to calculate logarithms with bases other than the natural log and the common log. So first, if we have in this example log base 3 of 16, we can use the common log to rewrite this. So this would be the same as log base 10 of 16 divided by log base 10 of 3. Now you would just go to your calculators and type this in, and you would get approximately 2.524. 2.524. When calculating these logarithms, go to 3 decimal places. Okay, that way we're more accurate. The one down below, we have log base 6 of 10. We can rewrite this using the natural log. So this would be the same thing as the natural log of 10 divided by the natural log of 6. Again, now we have it in a base we can work with. We plug this in a calculator, you get approximately 1.285. Again, go to 3 decimal places to be more accurate. So that's the change of base formula. Really quick, really simple. Allows us to calculate a logarithm written in any base. So in this lesson, we talked about the 3 properties: the product, quotient, and power properties used to condense and expand logarithmic expressions. And then last, we just talked about the change of base formula, which allows us to rewrite any logarithm in any base and then calculate that value.